This video is part of the quick start guide of the Builder Brain to get you up and running with one button, one potentiometer, and one LED. Advanced users may want to skip this video because it's going to really focus on just the basics of electronics and wiring for the Builder Brain, but it can also serve as a really good tutorial to show you how everything's connected and how everything's wired. So, when you purchase your Brain, it comes with 3 ribbon cables, a 10-pin ribbon cable, a 16-pin ribbon cable, and a 14-pin ribbon cable, 1 push button, 1 rotary potentiometer, that's a 100K linear rotary potentiometer, 1 LED, and 1 resistor to go with the LED. The parts that you receive might look slightly different, but in function and in form they should be exactly the same. First, we're going to start with the button, which is a momentary push button to serve as a digital contact for the Builder Brain. To start, we're going to need to find the 14-pin ribbon cable and the 16-pin ribbon cable. Now, what you're going to want to do is take your ribbon cable. It comes with 2 ends to it, and you want to cut it in half using a pair of scissors or a wire cutter, and just cut them in half, and you want to create 2 sides to them. I'm going to start with the 16-pin ribbon cable, which looks like this. So what you're going to need to do is locate the 16-pin ribbon cable, and you'll notice it says 16 on it, so it also has 16 wires, so you know which one it is. And it has 16 connections on the underside, which go to the male counterpart on the Brain that has 16-pin connections. So you're going to take the first and second wire on the 16-pin ribbon cable, and you want to pull them away from the rest of the wires so you can access them and strip them. Now I'm going to be just using a razor blade to strip them to show you how you don't really need professional tools to do this. So you want to just take the razor blade and slightly score around the plastic shield that is shielding the wire and pull it off to expose the bare wire. Do the same for the second wire coming off this 16-pin ribbon cable. Now, taking the 16-pin ribbon cable, you want to locate pin 1. Pin 1, again, is always the red wire that comes off of the cable, so you can always know that it starts here with pin 1 and it ends here with pin 16. So take the first pin, which is the red wire, and connect it to one side of the button. Now with buttons, it doesn't really matter what side you connect it to, especially with a direct wire momentary push button like this, because it just completes a circuit here when you press this button. So you want to take one side of this and solder it. Now these push buttons have little solder lugs here, so you can easily just fill it up with solder and create your connection. And then you're going to want to take the other side, and the side that's not connected yet, and find your 14-pin cable. Now with the 14-pin cable, you're going to want to strip 2 wires on it. The first wire, which is wire 1. So I'm going to go ahead and strip wire 1. And the second to last wire, which is wire 13. Now for the button, you're only going to use wire 1. We're going to use wire 13 later on, but you might as well go ahead and strip this right now. So with the 14 pin stripped, let's take wire 1, connect it to the other side of the button, and solder the connection to complete the button soldering part of the quick start. Okay, now that we have the button soldered and connected, we need to go ahead and connect the ribbon cables to the board. Now, you always want to use ribbon cables. The board comes with 3 ribbon cables to get you started. You can cut them in half, so you really have 6 ribbon cables, but If you don't have any more ribbon cables, you can usually find these at any good electronics store or from Mauser or DigiKey or any online electronics. They're pretty cheap, and they allow you to connect directly to the brain. You never want to solder to any of these wire pins. While it might work, it could damage the board. So you always want to use a ribbon cable or some kind of cable in between the board and your component. So now we have to attach the cables to the board. So locate JP1 on the board, which is the button matrix. It says button matrix right on here, JP1. And you want to locate your 16-pin ribbon cable, which is the one that says 16 on it. And you want to find pin 1 on the board, which always has an arrow. See all the arrows on each pin header. So this arrow designates pin 1, and the red line designates pin 1. So you can go ahead and connect that to the board. Now you want to take the 14-pin ribbon cable and you want to locate JP3 on the board, which is the external pin header. Locate pin 1, locate pin 1 on your ribbon cable, and line it up and plug it in. Now I always double check the connections here to make sure there's no pins loose on either side. Make sure you have the right size pin header with the right size ribbon cable. So that's all connected, and there I go. I have my button connection for my 3-component controller here. The next thing we're going to connect is the rotary potentiometer. This is the rotary potentiometer. Potentiometer is basically an analog control that controls the resistance between the positive and the ground, and moving this back and forth adjusts that resistance. So you'll notice that your rotary potentiometer has 3 connections here. One is for positive, one is for ground, and one is for wiper. The wiper is always located in the center on these potentiometers. There are various different kinds of potentiometers. There's panel mount, there's board mount, there's surface mount. This is a panel mount. It has a nut here, so you can put this onto a control panel or any kind of faceplate to create your own controls. You can put a knob on top of it. This right here is a board mount. This would go directly on the board here, and you would solder it from beneath, so you'd have a circuit board to always use. But for this quick start, we're going to be using this linear rotary potentiometer. Holding the potentiometer facing you with the pins facing you at 6 o'clock, the pin on the left is going to be ground, the center pin is going to be the wiper, and the right pin is going to be your voltage. To use the potentiometer, you're going to need to locate your 10-pin ribbon cable. That's the ribbon cable with the 10 on it right here, and has 10 cables coming off of it. Now, on the board, you have 8 different headers here for your analog connections. Your analog connections are going to be your faders, your potentiometers. So you can connect up to 64 directly on this board. We're just going to connect 1. Each ribbon cable can handle up to 8 analog controls. We're just going to use 1, so we're going to need to use pin 1 here, which is the red cable. This is going to be our ground. Pin 2 is going to be our voltage. And pin 3 is going to be our wiper. Now, if I had more than 1 potentiometer hooked up, say I had 2 potentiometers, this would always be ground and voltage. This would be wiper for potentiometer 1. This would be wiper for potentiometer 2, and so on. That goes for all the pin headers here. Pin 1 and pin 2 are always ground and voltage. So you're going to need to go ahead and strip the ends of these 3 wires here. When you're soldering these connections, you always want to make sure that the component is not near the board, because you don't want to drip solder on the board, because that could potentially destroy your board. So I'm going to take my ground connection here, connect it here to pin 1. It has these nice solder lugs, so you can just feed your wire through and use this little hole to solder your connection. After I have my ground connected, I'm going to take pin 2, which is the second cable, and with the potentiometer facing me at 6 o'clock, with the holes facing me, I'm going to feed this through the rightmost solder lug or connection. If you're not using our potentiometers that came with the kit, using a different potentiometer, you want to locate the connection to the right and solder that connection down. Now I want to take the third wire, which is the wiper, and connect it to the center connection on my potentiometer. It's a good idea to double check your connections after you have soldered, make sure everything's in place and sturdy, and there we go. I have my rotary potentiometer completely connected. Again, JP7 to JP14 are your analog controls. You always want to start with JP7. So I'm going to find pin 1 on my ribbon cable, which is the red cable. And I'm going to find JP7, which is this second header right here, and the arrow, which indicates pin 1. Line up my red cable with the arrow on JP7 and gently connect it to the board. There we go. Now our analog control is connected to the board and our buttons connected to the board. Now the LED that's included is called a through-hole LED, which is an LED that looks like this. These can be used surface mount. There's different sizes that you can get. There's different colors that you can get. All LEDs need a resistor to work, so you're going to need to use our wiki to locate the resistor needed for the LED that you're using. The resistor that comes with the LED in the kit is a 47 ohm resistor, which we'll be using with this LED to get it to light up. You can connect 14 LEDs direct and more than that in a matrix connection, but we're just going to be focusing on this one LED here. Now each LED that you'll use, through-hole LED, you'll notice it has 2 legs on it. One leg is long and one leg is short. The short leg is the negative, and that's the cathode, and the long leg is the positive, and that's the anode. It's important to note this because this is going to determine the wiring based upon the length of the pins here on the LED. So with the LED, we're going to be using the external pin header, which is already connected, and it's using the button for the buttons as well. And we're also going to be using the LED matrix, which is another 14-pin ribbon cable. So you cut this 14-pin ribbon cable in half. So you're going to want to locate the other half of that 14-pin ribbon cable. And you are going to want to strip the first cable on that ribbon cable, which is the red for pin 1. Since we're only using one LED and it's a direct wire LED, we only need to use the first wire on this pin header. Now I'm going to disconnect the external pin header here because we're going to be using the 13th cable coming off of this pin header, which is 3.3 volts. So this is going to be our positive connection. The positive connection is what requires the resistor. So using the 14-pin ribbon cable that's already connected with the button, we're going to take the resistor and we are going to just connect this cable here and solder it down. The reason I took it off of the board is because you don't want to solder connected to the board just in case something drips or you heat one of the pins up too much. You just don't want that to happen, so just disconnect it from the board. So now I have my resistor connected to pin 13 on this 14-pin ribbon cable that I had just unplugged from the external pin header. And now I want to locate the long leg of the LED. Take the resistor and connect these two. Solder that down. Now you normally wouldn't solder an LED just loose like this. You'd probably want to use a breadboard like this or one of our circuit boards, and you'd put the the LED on the through-hole connection, and there's also a surface mount spot for an LED on these boards. But since we're just doing a real basic quick start on how this stuff works, you can just solder everything here directly. So now I have this LED soldered to the long end with the resistor to the 13th pin on this 14-pin ribbon cable. So now I'm going to take the loose ribbon cable, locate the short leg of this LED, which is the negative, and connect it to the first pin, which is the red wire on the unconnected 14-pin ribbon cable. And then you can just go ahead and solder that connection. Now that I have all this connected, I can go ahead and connect everything back up to the board that I disconnected, and I can reconnect the LED connections. So I'm going to take the pin header for the external, which is this 14-pin ribbon cable. I'm going to make sure that this red line lines up to the arrow, and plug this into the external. The external connection is going to have the button and the LED connected. And then you're going to take the other ribbon cable that you have left over that you haven't connected yet, the 14-pin that's connected to the negative end of the LED. You're going to go ahead and connect that to the LED matrix pin header, which is JP2, making sure the red line lines up with the arrow. So there we go. I have my LED, I have my button, and I have my potentiometer. Once you have everything connected, you're going to need to configure the brain so it knows how many analog, digital, and LED connections you have. First thing you want to do before you open the software, the brain editor software, is plug the USB cable in to make sure you have power. This little blue LED here should light up, indicating that the board has power and it's communicating with your computer. After you plug the board in, you want to go ahead and open up the brain editor application. When you first open it up, there's a top menu bar that has all of the different functions that the brain editor can do. For now, really the only thing we're going to have to worry about is configuring it. Press the hardware configuration button to open up the hardware configuration. This lets you set how many inputs you have on the board. The only section we're going to have to worry about right now is the direct connect section. The matrix connections is for more advanced matrix connections, but using this directly connected button, potentiometer, and LED, we only have to worry about this section here. You'll notice that the buttons here to select how many buttons you have are laid out just like the 16-pin header on the button pin header. So since we only have one button connected, we're just going to highlight 1, and then we're also going to enable pull-ups on pins 1 through 8. What this allows you to do is use buttons without a resistor. Analog controls, which is our potentiometer. We only have one potentiometer, so we're just going to select one number of analog inputs, and we're going to leave first AD jumper index at 1. JP7 is the first jumper index, and that's where we started. If we had started at JP8, we would change that number to 2. Direct connect LEDs. You can have 14 direct connect LEDs. Since we only have one, and it's on the first pin, we're going to go ahead and select that. And that is our configuration. So your screen should look exactly like this. This is the actual hex string that it sends to the board to know how you've set it to be configured. And go ahead and hit send once you have that connected. And you notice this window will turn green here. That means that it's been sent. And then you're going to need to press Save to Brain. What Save to Brain does is saves it to the actual microcontroller on the board. So when I unplug it, it saves that setting to the board itself. So I plug it back in, it knows exactly what it is. So you need to hit Save to Brain, and that will write the configuration we just set up directly to the brain itself. So now we have the hardware configured. We need to actually see it doing something. So to view the button and the potentiometer inputs, we're going to click View MIDI, and you'll see when I press the button here, it sends a note on and off message, on being 0, off being 64. So I can use this button, and it's just creating a simple button contact. Potentiometer will send 0 to 127. So when I move this, you'll see this going from 0 to 127. Now, to get the LED to light up, you need to open up a different window, which is Send MIDI, because the LED is receives MIDI message to make it light up. So if you're using one of our button pads, there would be an LED under this. So when I pressed it, you can send a note to the brain, and the brain can send a note back to it to light it up. So I'm going to open up the Send MIDI window, and I'm going to change the duration here to 2000. Just type that in. And what I need to do here is go. Now it's set to note 0, which is the note it actually is mapped to. So I'm just going to go up from there and then go back to 0, and it should light up like so. So you can see the LED lights up for 2 seconds when I send it MIDI. So now that we have this all working in a hypothetical situation here, I'm going to go ahead and open up Live and show you what it would be like if I use this as my controller. To see the LED a little bit better, I'm going to turn off some lights. Alright, so now I have my controller set up in Live's preferences. I have it selected as the input and output device. I also have the MIDI ports, the inputs and outputs set for the Livid Brain. And now what I need to do is turn MIDI Learn on and make these controls do something. So I'm going to go to this first track here, and I'm going to use this button here to trigger that. I'm going to go to volume here and use my potentiometer to control volume, and that should do it. So now when I press this button, now I'm just continuing to replay this. You'll see the LED lights up as this track's playing. If I played another track, it would stop. It just keeps replaying, and I can use this to control volume. So there you go. I have my own MIDI controller here. So that's it. That's the quick start. This should get you started. Turn the volume down. And get you started on your way to build your own controller.